Good afternoon, fellow kids. Have you ever wondered about the different forms of energy that are used to spin the wheels of your car or make a ball bounce high up in the air? Well, you're in luck, because today we're going to be briefly talking about work and the different forms of mechanical energy. Before we start, what is energy anyway? Well, energy is the quantitative property that is transferred into a system, recognized by its ability to do work. For example, electrical energy can be transformed into mechanical energy by spinning a motor in order to do work. There are many forms of energy, but for today, we're going to be focusing on mechanical energy, which includes kinetic energy, gravitational potential energy, and elastic potential energy. Kinetic energy is the energy of motion. Everything that moves relative to something has kinetic energy. It is represented using the equation kinetic energy is equal to half times mass times velocity squared, and can be derived from these equations over here. Well, here's an example of a kinetic energy problem. A cannonball was shot at a constant velocity of 30 meters per second. If the cannonball has a mass of 20 kilograms, determine the total kinetic energy of the projectile. Well, here you can see the mass is 20 kilograms and the velocity is 30 meters per second. Using the equation we've gotten from before, we can just plug those numbers in, and we got around 90,000 joules of energy. Gravitational potential energy is the energy an object has by virtue of its height relative to a floor or ground surface. It is represented using the equation gravitational potential energy equals mass times gravitational acceleration times height. It is derived by these equations over here. It is very simple. We just change the acceleration for gravitational acceleration and distance for height. Here is an example of a problem involving gravitational potential energy. Cliff jumper jumps off from point A and landed on point B. If cliff jumper's potential energy from point A to B is 37,000 joules and he has a mass of 200 kilograms, determine the potential energy of cliff jumper from point A to the ground, that is 10 meters below point B, assuming gravitational acceleration is 10 meters per second squared. Well, we already have a bunch of variables here. So first, we're just gonna have to find what the height between point A and point B is, which is around 18.5 meters. Then we can find the total potential energy from point A to point C using this equation, and it totals around 57,000 joules. You can also use this other equation. It adds the potential energy from point A to point B, which is 37,000 joules, with the potential energy from point B to point C, which will equal out to be the potential energy from point A to point C. Elastic potential energy, on the other hand, is the energy stored within an elastic object, like rubber or some springs. When they are deformed, they exert a force wanting to go back to their original form. It is represented with the equation elastic potential energy equals half times the spring constant times the change in length to the power of 2, which looks suspiciously similar to the equation for kinetic energy. Nevertheless, it is derived from these equations over here. Here is an example of a problem involving elastic potential energy. An angsty cat plays around with a little spring that has a spring constant of 1000 newtons per meter. If the spring was displaced by 5 centimeters, how much potential energy is stored within the spring? Well, you see this very angry cat here. We know these variables here. We're just gonna change the 5 centimeters to 0.05 meters for consistency, and we're just gonna use the equation we got from before, and it equates to around 1.25 joules. Well, that's all I have for today, so thank you for watching my video, and stay cool.